Good morning. I am Dr.S.ARUNKUMAR, Assistant Professor of Mechanical Engineering, SNS College of Technology. So in the lecture series, I am going to discuss about the internal combustion engines. So in this way, I am going to present. This is my presentation overview. So definition and principle of internal combustion engines and primary classifications based on the combustion process, engine cycles, cylinder arrangements, and cooling system, and the air intake. And some of the real world applications like automotive, passenger and commercial vehicles, two-wheelers like sports, cruiser and off-road vehicles, and marine and power generation, stationary backup applications. Following by the design thinking methodology and some of the key takeaways like categorization of design features, classification of dictates application suitability, and emerging tech hybridizations. So first, we need to know what is internal combustion engines. So an internal combustion engines converts the chemical energy from the fuel into the mechanical work through the combustion within the confined chamber. The confined chamber is nothing but it's called cylinder. This process generates the high pressure gases that drives the piston or rotor, producing the rotational motions. Some of the key principles are fuel burns inside the engine cylinder, unlike the external combustion engines where the fuel burns in separate chambers. For better understanding the internal combustion engines, the combustion takes place inside the cylinder, like spark ignition engines, like petrol engines and diesel engines, best examples of internal combustion engines. And external combustion engines the combustion of fuels takes place outside the cylinder. So the best examples of external combustion engines are power plant, gas turbines are. So the internal combustion engines power most vehicles globally and remain fundamental to modern transportations and power generation systems. So some of the primary classifications of internal combustion engines based on the combustion process, it is categorized into two types. One is spark ignition, that is SI engine, and combustion ignition, that is CI engines. The another name of spark ignition engine is petrol engine, combustion ignition engine is diesel engines. So coming to the spark ignition SI engines, the air fuel mixer ignited by the spark plug. So the petrol and gasoline as used as the fuel for these engines. Homogeneous charge and lower compression ratio, the ranges between 8.1 to 12.1. Coming to the compression ignition, that is diesel engines, the auto ignition from the combust air heat. Here the fuel injector is used. So diesel is used as the fuel, and heterogeneous charges, the high compression ratio ranges between 14.1 to 25.1. So classification based on the engine cycles, there are two types, 4-stroke cycle and the 2-stroke cycle. In the 4-stroke engine, each stroke is completed by one revolution of crankshaft. So intake, compression, power and exhaust. So in the 4-stroke cycle, 2 crankshaft revolutions per cycle, the higher efficiency and smoother operations widely used in the automobiles. Coming to the 2-stroke cycles, the combined intake as well as exhaust with the power stroke, 1 crankshaft revolution per the cycle, the higher power to weight ratio, it is a simpler in design, common in motorcycles as well as the small engines. So classifications based on the cylinder arrangements, there are 4 types: inline configuration, V-type configuration, flat or boxer configuration, and radial configurations. The cylinders arranged in a single row, the compact and simple, cost effective, commonly in 4 and 6 cylinder engine, it is called inline configurations. For V-type configurations, cylinders in 2 banks at an angle, the compact length, balanced forces, the varieties of V6, V8, V12 variants widely used. Flat or boxer configurations, horizontally opposed cylinders, low center of gravity, excellent balances, used by force and the Subaru. The radial configurations, cylinders arranged radially around the crankshaft, excellent cooling and high power. These are the properties of radial configuration engine. And historical aircraft engines, these are the applications. Some additional classification criteria based on the cooling system, air cooled system and the liquid cooled system, based on the air intake, naturally aspirated air intake system as well as forced induction air intake systems. So some of the real world applications are automotive transport. The passenger vehicles predominantly use inline 4SI spark ignition engines or V6, V8 configurations. Diesel compression ignition engines dominate the heavy commercial vehicles and lorries due to the superior torque and the fuel efficiency. Marine propulsions, the large marine vessels utilize the massive two-stroke diesel engines reaching up to the 14 cylinders, delivering the exceptional fuel efficiency and reliability for long distance maritime transports. Two-wheelers as well as the power generation, these are some of the real world applications. So coming to the design thinking approach, empathize stage, understand the user needs before designing or improving an engine. Engineers must deeply understand the user's requirement and the constraints. Some of the requirements and constraints are identify the stakeholders, gather the requirements and analyze the operating conditions like load profiles, ambient temperatures, fuel quality and maintenance capability. So design thinking approach and the prototype stage, concept selection, it choose optimal engine classification, whether it is a spark ignition or compression ignitions, cylinder arrangements based on the empathize, finding and the performance targets, and rapid prototyping, build the physical prototype of critical components, test the combustion chambers, designs and intake the manifold configurations. Finally, the iterative testing to be done, conduct the dynamometer test, measure the emissions and analyze the performance data, refine the design based on the results. Some of the key takeaways of in the engine classifications or classification framework, like it is categorized type SI, CI or 2-stroke or 4-stroke based on the cycles and design considerations as well as the engineering approach. Apply the design thinking methodology, empathize with the user, get the requirements and the points from the users, a prototype to be formed, solutions to select the optimal engine configurations for the specific requirements. So these are some of the reference I have to prepare for this lecture. So thank you for your watching.